Hello, this is Jim Whitehead of SaleServe and Power SaleServe. Today I'd like to go over and describe and give you the tools to help decide what size generator you would like for your home. The first questions that are important: one, do you want to run your whole home? That's everything at any time that you require. Or do you only want to run a certain, what you might call, emergency loads? First of all, to come up with a plan, especially if you decide that you want to run your whole home, there are four areas or four methods that we use to decide the proper size generator. One of them is we would ask for, let's say, 12 months of your power use via your FPL bill. That gives you a total kilowatts, and we'd be using that to come up with averages of your typical power use. Another area is a direct measurement of your power usage, and that would be by putting equipment on your electrical service and measuring volts, amperage, and watts, for example. The third method is using a spreadsheeted load calculation process. This is where we use the size of your home and the appliances that you have and the ACs that you have, and we come up with a real world running expectation of the power use in your home. The fourth method we don't use too often, but that is taking the electrical service that is coming into your home, and let's say, for example, it might be 200 amp service, or two 200 amp services, or two 300 amp services, or two 400 amp services, and we install a generator that is geared toward that total power option. We don't use it too often, mainly because it would require a very large generator, and in very few instances are you using every bit of power that can be delivered to your home. Let's go over some side points, some things that you should know in helping you decide what is the best choice. Typically, you are never running all of your equipment and appliances all at the same time. That's good. All equipment uses a certain numbers of watts, amps, and volts. Motors, and this is important, motors like pool pumps, AC compressors, AC heat, take a significant larger number to start the item than to run the item. So using AC compressors, for example, to start up your AC, it takes typically 4 to 5 times what it would take to just run that air conditioning. So we have to take that into consideration in helping deciding what you would need to start items, and making sure, for example, that things are not running or starting at the same time. Also, some of the equipment runs on 240 volts, and some of the equipment in your home runs on 120 volts. Typically, air conditioners and water heaters use and need 240 volts. TVs, refrigerators, for example, DVD players, computers, all run on 120 volts. Now, FPL supplies 2 lines of power to your home. Each line is 120 volts, and in combination, we get the 240 volts. So accordingly, we have the opportunity to run those items that need 240 volts, like the AC, as I mentioned, or the 120 volts, like your computers and TVs and refrigerators. The breaker size, as you know, with the line coming to the side of your home, you have what we call a service disconnect or service entrance. But each one, if it's 1, 2, 3, or 4 or more, has a certain breaker size in amps. That could be 100 amps, 200 amps, 300 amps, 400 amps. And that gets into, again, what is the maximum amount of power that can go to your home. If it did by chance go above that point, it would pop that breaker, as we describe it. Those items that are being powered by that particular service would shut down, Or with a generator, it would tell the generator, in essence, that the generator would know that you lost your power, and it would start up and supply the power for those items. Some additional points. The generator, just as FPL, delivers the 2 lines of 120 with the combination 240 that we need. Now, the only difference between what you get from FPL and what you get from your generator, first of all, is with FPL you get almost an unlimited number of amps. If you think about it, when there's a major power loss in an area and everything is off and it's hot, when they are able to resume, get the power back on, you can imagine the amount of air compressors, air conditioner compressors that basically have to start, and they all take significant amounts of amperage. So accordingly, FPL delivers generally to its customers almost an unlimited number of amps. The generator, though, depending on the size, will only deliver a certain amperage, period. It does have the capability, the generator, of increasing for very short periods higher so that it can accommodate some of the motors and AC or heaters that you are running. But the big point of the calculation is ensuring that things can run the items that you basically need. With my load calculation method, I use a spreadsheet, and we first of all add a certain number of lighting related to your square footage. A smaller home has less lighting, a larger home has more lighting. A hot water heater, for example, is 4,500 watts. And by the way, installing a solar hot water system can remove this need. You can actually take your hot water completely off the grid. Also, by having gas on your site, which you would have and would need to have or installed, you could also run a tankless hot water system that either runs on propane or natural gas. That will also take that number away from the electrical calculation. With the solar, for example, you can add a 10 by 10 inch solar panel to the water collector, and the pump is a DC pump, and it pumps your water basically by the power it pulls from the little solar panel on the solar collector. Your range, oven, dryer, refrigerator, microwave, coffee maker, they all go into the calculation. We also need to put in all your ACs. We need to put in and list all the startup amperage for the items, and the tonnage, and the running power that these units need. So those are 2 very important calculations. They go into the total. Now what our spreadsheet does, it gives a total number of amps needed and watts needed. Now typically no one would be running more than 80% of that total number that we just put together. The additional point is we put into the calculation special sizing for special circumstances. What I mean by that is we need to allow overhead room for a change in future power demand. And that would be if you are going to add an addition to your home. Obviously, adding an addition, you'd be having the need for maybe another AC. That's 240 volts and amperage, lighting, computers, so on and so forth. So we really find it important to look to the future to ensure that you are going to have that power that you need for the future. Now, on the other side of that, the good news is when you replace an appliance, whether it's a refrigerator or dryer, the newer energy efficient units use less power. So you again would be ensuring that you have the power per your generator for the future, and you also save money in the meantime. Also, whether we work on running individual items, an emergency panel, or we run your whole home, and believe it or not, there isn't that much of a difference in pricing when you work out the numbers, but it is imperative that any plan any generator plan size has where you at least have air conditioning, hot water, refrigeration, cooking, lighting, and TV. I will try never to install a system that is smaller that would compromise that minimum safety and support for you. I am a Generac dealer, and there's so many different choices of generators, but just to give you an idea, when we do come up with a total number, the number that we feel is a accurate and reasonable wattage use, we have the choices then of certain models. Firstly important part is that we install a unit that basically has an aluminum case. Steel is not very good. It is not a good idea for Florida. Also, I like to sell generators that run at 1800 RPMs versus 3600 RPMs. They're quieter and they use 20% less fuel. Some of the units that we install, again, saying I'm a Generac dealer, and the models that I have available to my use, we could do 17 kW, that's a 17,000 kilowatt unit, 20 kW, 27 kW, 36 kW, 48 kW, 70, 100, 130, 150. How we come to the best choice is, again, looking at the total use of wattage. We make sure we've added a future need, and we kind of round up, I guess you might say. So if we calculated that you need 37 kW or 38 kW, we wouldn't go down to the 36 kW, we'd go up to the 48. And as I mentioned a minute ago, the prices are not that significant between these models. I want to thank you and extend my appreciation for your attention. I'm always available, toll free, 866-535-5199.